Hello and welcome to Math with Ms. V. Today we are looking at solving one-step equations, specifically with integers that have only one variable. So in previous videos, we have looked at solving expressions. And as a reminder, expressions do not have equal signs. Expressions cannot be solved unless the variable is defined. For example, if we had x plus 2, we would need to be told what x equals. And expressions can be simplified by using the distributive property or by combining like terms. In this video, we will look at equations with one variable. So equations do have equal signs. Equations can be solved for the variable or the unknown, but work has to be undone in order to solve. So there's a few things we need to look at first, and that is how we undo work. So we have what are called inverse operations. They're operations that undo each other. So our first operation we want to look at is addition, and we would undo addition with subtraction. So if I was saying x plus 2, I would undo my adding 2 by subtracting 2. On the flip side, if you have an operation of subtraction, we would undo that with addition. Our other two operations, multiplication and division, are also partners. So we undo multiplication with division, and we undo division with multiplication. Now, I know there are a few other operations such as exponents and square roots and that type of thing, but we're only going to concentrate on our big four. So let's jump right in with a few examples with addition. So we undo addition with subtraction. And what I like to tell my students, and I heard it from another teacher, is think about your x as a zombie, okay? And it is trying to eat your numbers. So the equal sign marks safety. So we're going to put a line through our equal sign so we know where safety is. And we're going to circle our variable so that we can keep an eye on it. And we can move numbers across the wall to safety by undoing them. So this is being added, and we're going to undo that by subtracting. What we do to one side of the equation, we have to do to the other. So a positive 6 and a negative 6 are opposites. They make a 0. So we're left with just x equals whatever 15 minus 6 is, and that's 9. And we can double check our work and say x plus 6. We're going to replace our x with 9. 9 plus 6 does equal 15. Okay, our next example, we're going to put our wall. We can find the m here. So the m's already with the 7, so that means the 12 is the safe side. So our 7 is positive. The opposite of a positive is a negative, so we can think subtracting. So 7 minus 7 is 0. These cancel out. We're left with a positive m, or just m. Okay, these are the same sign, so we think that we're adding. Same signs add, keep the sign. So negative 12 plus negative 7 equals a negative 19. And we can again replace the m with 19. To check our work, and we get that the answer is indeed negative 12, like we wanted. Our last addition example, so we have f plus negative 4. Okay, so we're going to, the opposite of addition is subtraction, but we also want the opposite of a negative 4. So this is actually easier to think about as f minus 4. So a little bit of an introduction to our subtraction. So the opposite of subtraction is addition. The positive and the negative of the same number make a 0, so we're left with just f equals 15. Okay, so those are our addition examples. Let's look at some subtraction examples. So we're going to start with the same way. So circle your variable, put in your line, If you like the zombie example, you can keep going with that. So we're trying to rescue the -5, so we can move it to the other side by doing the opposite. That's +5. Positive and a negative of the same number make a 0, so we're left with A equals 23 plus 5 is 28. And we can check our work. A minus 5, 28 minus 5 equals 23. And that's what we wanted. Okay, put in our line, circle our variable. So we have a -3. We want to do the opposite. That's a +3. Positive and a negative of the same number make a 0. So Z equals. These are different signs. My integral rules say when my signs are different, I subtract. 14 minus 3 is 11. I have 14 negatives, 3 positives, so I have more negatives, so this is a -11. Okay, last example. So with this one, I would do like we did on the previous and follow your integral rules for subtracting. So rather than saying k minus -10, let's say k plus 10 equals 6. Put in our line, circle our variable. Opposite of addition is subtraction. Positive and negative of the same number make a 0. K equals, okay. This is a +6. Different signs tell me to subtract. 10 minus 6 is 4. I have more negatives, so K equals -4. Okay, so let's look at some multiplication examples. So remember, the opposite of multiplication is division. And we show division in this case by using the fraction method. So we're going to put a bar under each side. I still encourage you to put in your line, circle your variable. So when we multiply and divide by the same number, it makes a 1. So we have 1b, but whenever we multiply anything by 1, it doesn't change. I tell my students that a +1, when it's multiplying or dividing, is very lazy. It pretends like it's there to do work, but it never changes your answer. 14 divided by 7 is 2. And we can check our work. 7b, which is 7 times 2, which gives us 14, like we started with. Okay, put in our line, circle our variable. Again, we're multiplying. We're going to undo multiplication with division. Now, if you go with your zombie storyline to help you keep things straight, think about negatives as pets. You would rescue your pet, hopefully, in a zombie apocalypse, if you could. So the numbers take their pet negative with them when they're running to safety on the other side of the line. So multiplying and dividing by the same number gives us a 1. So we're left with S equals 10 divided by 2 is 5. A positive divided by a negative is a negative. Okay, last multiplication example, we put in our line, we circle our variable. 6 times g, we undo multiplication with division. Times 6 divided by 6 cancels, we're left with g equals. 18 divided by 6 is 3. A negative divided by a positive is a negative. So those are examples with multiplication. And now we're going to look at our last set of examples, which is division. So we undo division by using multiplication, and I've set it up in 2 different ways. So the first is using the division symbol, which is not that common. You won't see it that often in equations. You will generally see division set up as a fraction. So we undo division with multiplication. So times 6, forgot, I need to drop in my line and circle my variable, times 6. Multiplying and dividing by the same number cancels out, and we're left with E equals 4 times 6 is 24. We're going to undo our division with multiplication. When you see it set up in the fraction method, the most common way to show what you're doing is to put the multiplication dot and put your 5 out to the side. What we do to one side of the equal sign, we're going to do to the other. So times 5 divided by 5 cancels. So y equals 5 times 8 is 40. A positive times a negative is a negative. And let's just check this one. We haven't checked any division work yet. So y over 5, so that's negative 40 over 5. 40 divided by 5 is 8. A negative divided by a positive is a negative. And our last example. So remember when we talked about fractions in a previous video, we said that the negative could be out to the middle, it could sit with our numerator, or it could sit with our denominator. Because we are moving the denominator, I'm going to rewrite this so that my negative is with my 4. So I can go ahead and move it to the other side of the equation without having to do extra steps. So I'm dividing by negative 4. I'm going to undo division with multiplication. What I do to one side, I have to do to the other. Times 4 divided by 4 cancels, so I'm left with q equals 3 times 4 is 12. A negative times a negative makes a positive, so my answer is q equals 12. Thank you for coming by this Math with Miss V video. I hope it has helped you out, and I look forward to seeing you in the future.